Hello and welcome to DS30. My name is Michael Cullen, your host for today. And today we're going to be talking with Venchei Sanders, who is an analyst with Shipt, and he has a focus on machine learning. And Venchei and I are going to talk a lot about our experience as teachers and educators and how that's informed our work as people in data practicing roles, the way we communicate with people, and the way we think about the work that we do, and what that means for people who are, whether you're breaking into the industry, whether you are in a data adjacent role, kind of what we can take away from that. All right, let's get right into it. All right, well, hi, Venchei. Thanks for taking the time today. I appreciate you stopping in, so to speak.
Thanks for having me. How are you?
I'm doing well, thanks. So we've got a lot to get into today. And I think probably the best thing to do would just be to start with just introducing yourself, maybe talking about, where you are currently, current work, and maybe, what led you to this point.
Yeah. Hi. So I am currently working at Shipt as a data analyst focusing on our machine learning efforts. Before I was a math teacher, and in some respects, I think you can say that I probably stumbled into this space, but I'm finding it enjoyable.
I have a very similar background, and I think I've mentioned this a few times on the podcast, so it's probably pretty familiar to listeners at this point, perhaps. But in my current role with Pragmatic in the Data Incubator, so I'm one of our instructors here. I teach a number of things, including a 8-week fellowship we do, kind of helping people make that leap from education to industry. My background is in stats and math, and I feel in some ways like I sort of maybe stumbled into industry as well, finding that, oh, wow, this very theoretical stuff maybe doesn't exist so much in the real world. So I think that's, very cool. And I think it's going to give us kind of a lot we can get into. So as we were kind of just chatting about before we started, you wanted to come in and talk about kind of this sort of pipeline, or just sort of this transition from teaching to tech, and maybe how that's informed your current work, or how that just generally is what you think is maybe important in this field. So you want to maybe talk a little bit about that, kind of like how you bring some of those things from teaching into your current work.
Yeah. So when I first started my professional career, I initially, little known secret, I actually wanted to be a basketball coach, a college basketball coach. And so I thought I would just work my way into it. And so I became a math teacher, taught for a few years, coached basketball, and then sort of transitioned out. And so while I was a math teacher, I always loved applied math. And so currently you probably see this proliferation of analytics in sports, and a sort of basketball team like the Houston Rockets shooting more threes than twos, and the Golden State Warriors, they've really changed the game. And so I love applied math. And so that sort of gave me the idea of how can we actually use this stuff that I'm teaching the students. And I initially tried finance. And so I worked at a fintech in Nashville and found my way to Shipt. And so some of the cool things about teaching that I thought were sort of helped me transition were the communication skills, understanding hey, some of the methods I think we get caught up in, wanting to implement something cutting edge, but actually something more simpler is generally probably more useful and more easier to deploy or implement.
Mm-hmm. Absolutely. And I think there's something really poignant in that example of sports analytics, right?
Yeah.
So, you gave a metric or statistic just now, like you said, shooting more threes than twos. You don't need a neural network to tell you that. You need to know what to write down, and you need to ask the right questions, right? I mean, when people talk about, as a statistician, people always love to ask me, "Oh, you must love baseball. Oh, have you seen Moneyball? It's crazy." And what's really exciting about that field, I guess no pun intended, is that it was really about finding those indices, finding those numbers that actually had to do with something real and something that mattered. And there's something very human to that. And it's a different side of applying math than throwing something really technical at it. I was saying, is this something that you see, maybe in your current work, or maybe that you didn't see as much in your previous role, and that kind of led you to Shipt?
Even as a math teacher, as let's say a pre-service math student, and maybe as a statistician or statistics student, you might have had a slightly different experience. And so like what I found kind of lacking or dissatisfactory with me were just an emphasis on being like super, super technical. And I think that matters. And I think like doing math proofs and that sort of deal is very, very important. No doubt. But I think understanding more so like, hey, how can I use these sort of methods and tools in reality can probably lead to an increase in popularity of the space and even better understanding. Okay, so take, for example, what we do at Shipt. We deliver groceries and things from department stores, but like, are we really trying to like build a car that drives itself? No. So like, what are some of the things that I've done to sort of understand our needs for a business is I've actually gone out and did some shopping. So I've maybe delivered 60 plus-ish orders over my tenure at Shipt. And so I've gone around San Francisco, not supposed to do it, but skateboarding and delivering orders. And I've used those experiences to inform my work.
And, as a teacher, you kind of have to be a student, or at least at one point. As a coach, you would have had to be, like you would have been a player. You have to understand the game from the inside. And that's very different from simply looking at every possible number you ever could have written down and trying to find some, pattern in there that's devoid of context. So it's really cool to hear that you're doing that in your current work in a very direct, a very literal way. You want to talk a little bit more about how that's impacted you or what you found when you were, working as a shopper?
Yeah. So like, as a shopper, I want to say like some of the things that I found a bit aggravating were like just not understanding the task. And so, especially in like busier metros. And so like if you live in New York currently, so like when you go shopping, probably some of the things you care about is like how fast can I get out? In a big city, that's probably like a huge thing. Like you don't want to spend hours in there. And so that's one thing that Shipt does that's really cool is that it saves our members time. But on the opposite side, like as a shopper, you really want to know like how many items are in my order that I'm getting from my member. Is there like produce? Do I need to speak to somebody? Maybe that's a concern for you. And like where are these things located in stores? Where are these actual items located in the store? And so like in SF, maybe I'll go into an unfamiliar target. And so, like the anxiety of just the unfamiliar can make the job a hard thing to do. And so when I went out as a shopper, I looked for those pain points and I came back the next day, had a meeting with my boss and said, hey, like we need to tell the shoppers what's in this order. Maybe we need to surface a few more details. Maybe we need to add a map so that they can know where to look, as well as like maybe some drive time and additional like sort of metadata to make the process easier.
Got it. And I could imagine that the time to, get in and out of the store probably has been a big metric for Shipt for a long time, but you might not know the right way to help somebody with that if you haven't been, if you haven't gone through that struggle, right?
Exactly. I remember our founder saying he started the company because he had like kids and It was a struggle for him to get in the store. And so with his kids, and so like it's like, how can I solve this problem? And sometimes it's something maybe as like sort of math or I view myself as quasi quantitative. We like focus in on like, oh, well, there's this really cool math that I heard about. I heard about a decision tree. Well, okay, what is the problem actually that you're trying to solve? Like,
Right, exactly. This is something I see, and I see it kind of from both sides of the aisle. People get really excited about these really hyped technologies. So in this fellowship that I teach, the students, the fellows, they complete a capstone project, an independently led, industry-based, like they try to solve a real problem with data science. And I can't tell you how often someone comes in and they say, well, I'm going to use deep learning to do this.
Oh my.
And I'm like, okay, well, why? And they say, well, because you got it, it's the best. And, I say, okay, well, it's important to remember that these things are difficult to do. Like it's hard to do deep learning. It's hard to deploy it, even if you get the model working. And, are we sure it's better than, like you said earlier, is this going to be better than linear regression? Is this better than just splitting somebody up into two groups and saying, hey, this group is maybe doing better than this one? Mm-hmm. And, it's much better to make sure we're writing down the right numbers, that we're giving people information or decisions that actually matter, that we're, finding out the questions we should be asking. And I think there's something very poignant, again, in your shopping example. Like you said, maybe we need a map of this store. And I could imagine that's very different from, hey, this thing is in aisle 7. But maybe you're in Phoenix, where I'm from, and aisle 7 is like half a mile long.
Oh, okay.
This huge big box stores, and maybe a number like that's not doing that much for you. Where is it in the aisle? Is it, what does it look like? Might be meaningful too. Maybe giving somebody a list that's in an order that makes sense instead of 20 bullet points randomly thrown in or alphabetized. Maybe. Tell you what, I'm very bad at making grocery lists, and I end up doing laps and I get flustered. And if you've got any tips for me, that'd probably be great. But I think this stuff really matters. It's, you don't understand what someone needs if you haven't been there before.
Right. And so if you took or take a look at the article I wrote about the minimum time to shop, really the model that I used wasn't a sort of advanced model. Like we care about traversing the store and mapping it, but really when I looked at the problem, like, hey, we want to predict shop times. Okay, well, really, what does it mean to actually shop? Okay, so then as you go through the article, I developed what I called the grocery shopping axioms in theory. And so, it starts off like, well, what is an order? So an order has at least one product or one item. Okay, kind of like Euclid's elements, right? You start very basic. Okay, cool. We've got one order, we've got one item, at least one item. And then shop times are all positive real numbers. Now, that makes sense intuitively, but stating it and putting it out there actually really like sort of grounds the problem in sort of a realistic context. And so now I then go back to my database, and you'll see if you check out the article, there's a nice distribution. And we see that some orders had negative times, some orders had null times. And so like you can sort of see like with technology, some things in reality can be violated. And so like understanding, like those pain points in your data, being able to tease those out, that's really data science to me. And it's not necessarily just, wow, did I deploy recurrent neural net or something complicated, right. Something really, really complex.
And that approach you took, it's very applied in the sense that it's applying to the actual problem. It's very abstract and theoretical in the sense that you said, well, an order has a thing in it, and a time it's a number. And it seems like these things are at odds with each other until you, I think, realize that the applied isn't just mechanical. And the abstract isn't just, locked away in ivory tower academia world. It's how you think about things. And I could imagine from there you can say, okay, well, if we have one thing, what takes time? Well, going through the line, finding that thing. If we have two things, what takes time? Well, going from one point A to point B, I guess, but maybe what order you do them in, how you organize things. And I could imagine a lot of that comes from those axioms, perhaps.
Yeah. So we when working on the project, I work with my boss, and I'm like, all right, so like I've really spent a lot of time just thinking about what is the actual task. I went out there, I shopped, I actually did the work, and these are some of the things that I noticed. Like, hey, when I do a smaller order, sometimes I can get through this faster, and so that's like axiom 3. Like as the number of items in an order increases, we expect the time to increase. That seems kind of like trivial. It's actually non-trivial. It's actually a very non-trivial notion. And likewise, when I was a teacher, I actually found like using the text like just unsatisfactory. I really wanted my students to know like, hey, we're using these things I'm showing you. You can actually use them to make better decisions. And that to me is what's cool about math.
Absolutely.
A method.
And that kind of combining the two sides of it, it's like saying, I'm not just going to tell you exactly how to, I don't know, price something. I'm not going to tell you exactly how to calculate a budget. I'm going to tell you, here's what you can use, and well, why does it matter? What do you need to worry about? And I think that's huge in this field. And I think that comes a lot from, I think experience in teaching really informs that. And also just, that again, I mean, I'm going to probably keep circling back to this, but at the end of the day, it's important to keep in mind, I think, teaching is a helping profession. Realistically, so much of what we do in, analytics and data science and what have you, it boils down still to a helping profession, thinking about how you serve somebody's needs.
Right, and that's exactly a focus of mine, and I hope of other data professionals as well, like staying close to the data, but also understanding that it's not just about the data, it's about people.
Totally.
Maybe that's sometimes, but it's actually about people, right? At least I hope.
So we've got kind of a few big ideas floating around here. On the one hand, we want to keep it simple. We don't want to go straight for the really cool technical stuff. Maybe axiom 2, if we're going to play this game, that we want to keep it real, I guess. We want to drill back into what actually happens, what's actually generating these things, not starting with just what we've already, again, written down, perhaps. I mean, anything else? Does anything else kind of jump out at you? What do we need to keep in mind when we're doing this kind of work? How do we talk to people? How we maybe get things, done better or faster, or just?
Yeah. So I think, like when I initially transitioned, some of the like knowing how to read the market or like the signals the market is giving you. So like normally in a job description or something, you would see skills such as SQL, maybe a scripting language like R or Python. As a user or practitioner in the data world, I use a lot of SQL. I use less R / Python, but a lot of SQL. And so again, I think like, knowing a more advanced tool is dope. It's super, super awesome. But when you're first starting out, again, keep it simple. I've actually found like using or leveraging just SQL alone can get you very, very far. And, even within my article, most of the underlying logic or code for it was like Markdown, which is a very simple text editing language. And a lot of it was SQL and very little of it was R. And so, you can build high quality work using just very, very simple tools.
Yeah.
And it's actually quite amazing.
It is, I've looked a lot at job applications for data analyst and data scientist positions. I mean, it's sort of, it's part of what we do, training people for these jobs. We need to know what they need to know. And at every step of the way, or every level, or every job title here, SQL is, you have to know it pretty much. You have to know how to do it and why you want to do it. And it's it's a pretty old tool. It's not cutting edge by any means. I mean, you have cutting edge services, I guess, that are, better for larger data sets. They're faster, they're easier, what have you, but it's structured data, it's tables. It's not that exciting to a lot of people, but you're absolutely right that it's really central, and I think that idea proliferates like across the work we do and across probably any field, right?
Yeah, I think again, just going back, and I feel like we're sort of like preaching to each other, but going back, like really, like when I first started at Shipt, hey, I took a SQL test, and I think like every interview I've had involves like, hey, can you extract some information from our database? Like foundational skill. So like really understanding if you want to break in, if you want to transition, not just from education or any other sort of sector of the economy, like really focusing on just your fundamentals and, like saving the ML, maybe saving that for later, but hey, you can get very far taking an average, taking a weighted average, understanding like moderate level statistics that are taught in like undergraduate courses. And like, how can you deploy those methods or leverage those methods within just SQL? And, I told someone at my current job, that's a colleague, like, hey, you want to learn R or Python, take what you know in SQL and implement it in that. Like and that'll teach you sort of the benefits of why, like, hey, why is dplyr super cool or super useful in this context and maybe SQL's easier in that. And that to me, just really focusing on your fundamentals is really, really a key thing. You don't have to get very advanced, just keep it simple.
Totally. And, with respect to like how we put that into practice, how someone who is, again, looking to break into this field, where would you want to direct somebody? Where should someone go to start doing SQL, to start learning how to do it, how to think about it? Were there any resources that you found helpful or experiences you found helpful?
Yeah. So I feel like I'm about to plug someone else's product. Very hesitant to do that, but I really love the O'Reilly stuff. I don't know if you've ever used their content. So I love their stuff. I love Coursera's stuff. After you've leveraged and extracted everything you can out of O'Reilly SQL books, going to Coursera, maybe like taking like Endring's course is super popular. That's a way to get started in ML. But yeah, I think like just leveraging, like I think you could get up to speed in SQL in like a week if you're really aggressive. Now, I think like there's a difference between being up to speed and being like super proficient. That might take you a month or two because you got to keep doing the work and like get some practice in. But I think like, yeah, just get an awesome book, read it, try to do something, find a cool data set, try to leverage that tool on those cool data sets, and then go from there.
Yeah, totally. One thing you mentioned there as well is that the best source is actually to use a wide range of sources, I guess, which is a sort of, I'm kind of escaping the question myself now. But seeing all these different contexts, right? Hey, I learned that over there. That's why I did that. Wait, I'm circling back to step one again. Even in, it was my experience like studying math. This happened over and over again. I was like, wait, that's like what a fraction is. That's what a rational number is. That's what linearity is. And these are very, abstract ideas, but, or wait, that's why linear regression is good. That's what sum squared error is. That's what R squared is. Wait, you can generalize like all these kinds of things. The more times you see the fundamentals, the more different contexts, the more those synapses start firing. You make those connections.
Right. And I think for me, again, like when I was a math teacher, trying to connect those things for the students, because sometimes it's kind of like, oh, why am I using Pythagorean theorem? Why are we learning these things? And I'm like, yo, like this is really, really interesting stuff. Like how could I leverage these math tools to make a financial decision, to make a better financial decision? And it's not, if you read the article, it's not the most technical article. It's not the quote, maybe it's not like a jazzy method, but it's practical, and we used it to sort of set a lower bound and like to inform our decision for a more advanced method.
Absolutely.
So, like that's kind of, to me, one of the coolest things about the piece in some of the work that we do in data.
Right. It's just, it's just so important to always come back to like those fundamentals, those first things, those best practices. It's like why, you never stop doing layup drills. You know what I mean? You have to keep working it. I've done this a million times, but you might do it better. You might learn something new. And that's, that applies to everybody, right? You want to be a lifelong student wherever you are in your path. Well, I tell you what, Venchei, we're coming up on 30 minutes here. That's the 30 in DS30. Maybe let's see if we can kind of recap what we've been through, kind of, take away for our audience. We have a lot of people who are, again, looking to break into the industry or maybe work in data science adjacent roles. So I think we went through a few things, right? We talked about keeping it simple and how that's not always easy, but it's a big deal. We talked about, relating stuff to the real underlying kind of phenomena that we care about, right? Figuring out what we care about. We talked about, kind of at the end, learning from multiple sources, finding those connections. And when we find those connections, sort of collaborate, we think more deeply. Aside from that, any kind of last send-offs or takeaways you'd like to leave everybody with?
Yeah. I think for one, if you're a teacher, shout out, you're doing killer work right now. I understand the plight, been there. I think if you're breaking into the space, again, just really focusing on your fundamentals, understanding like what is the problem you're trying to solve, who is your customer. At Shipt, I went out, actually, I still do it. I still go shopping. I try to stay close to the actual, like maybe first principles of the problem. Like, what does it mean to actually shop? Well, keep going shopping. And so, making sure you really, really understand your customers' needs, whether that's internally for your boss or externally for like a member or a client or a party that you're attempting to do work for. Just really knowing them and caring.
Wonderful. I really couldn't have said it better myself. And I'll second that shout out to all of our teachers and educators out there. All right. Well, thanks so much, Venchei. I really appreciate you taking the time. It's been great talking to you. Once again, we're going to link the article that you mentioned in the description, and people can, follow up on that and read about the really cool work you have done with Shipt. That wraps it up. Thanks again.